Now, when we look at semantic networks, that's something vital behind this. This is an example of Google's knowledge graph. A knowledge graph is basically a network of these semantic concepts, as I explained it, that are all interconnected and they have defined roles. And this allows Google to do interesting things. So if I look up the Napoleonic Wars, which you see there on the left, it will know, okay, Napoleonic Wars means this. I can pull this content from Wikipedia. I can pull knowledge about the date, the combatants, and all this becomes linked because these roles are defined. I just heard recently that traffic to Wikipedia, because of this, has fallen dramatically. Doesn't bother Wikipedia, they're still serving up the content, but most people are now accessing it through Google rather than going to Wikipedia and looking up the Napoleonic Wars. Another example you can see on the right is if I wanted to know about James Spader and I do a Google search for James Spader, I get all kinds of information about him, including his partner, his former spouse, his children, IMDb content about what he's been in. All of this is linked into a network of knowledge that allows Google to act intelligently upon this and serve up something that's going to be relevant to your particular use cases. Now, this is just the tip of the iceberg for what's going to be possible. I've seen some demonstrations from companies of things that are absolutely astonishing, like a company that could take content component management system, put it in, and actually start displaying content over an augmented reality headset to assist a motorcycle repairman in identifying exactly what part in an engine needs to be replaced. I mean, this seems like something out of science fiction, and yet increasingly it's real. Now, to achieve intelligent content, there's some things that are required. One is web-scale computing to process content. If you want to have these semantic networks, they have to be able to link out to content everywhere across the world. And the Google Knowledge Graph, I have no idea how many nodes, but it links, I'm sure, to hundreds of millions of web pages. And so this requires computing power that until 10 years ago simply didn't exist. And now so we're starting to see the fruition of visionary dreams from before because the computers can do it. You have to have access to information repositories, and these could be public and private. At the enterprise level, you have a lot of information that you may not want to expose to the public, but that you can use to enrich intelligent content applications. Information about SKUs, stock levels, all kinds of things you don't disclose, but could influence what you display to the public. It also depends on standards that support multilingual representation of meaning. And here I'm going to throw in the first cautionary note in this tale of great and wonderful things. These standards largely don't exist. The moment you leave English, you run into difficulty, and that's something we'll come back to. And then you have to have support from authoring and publication environments. It's great, you've got all these structures that can support intelligent content, but what happens if you try and author in Word and it doesn't support it, or FrameMaker? And so there has to be this level of support. Now, another way of looking at this history is that we see the shift, this will be familiar to anybody who's looked at the content management space, is you see the shift at the lower left from unstructured content up through the first generation of web pages, which start to have some structural information. Then you move into data and topic-based authoring that was really popular in the late 90s and through the 2000s. And once you've got that, then we start seeing human-curated enriched content, which is where machines are starting to add in this information. And you have humans playing a role of selecting what's important and adding value. And you arrive at the end point is this transformable, redeployable content. Through each step in this, the value of content increases because you can do more with it. And as you see from the axes, you move from the type of enrichment being nothing through hypertext links, structural elements, and up to semantic enrichment. And then on the bottom axis, you're going from something that humans created to something that may be created by automated processes where a human doesn't even touch it, but machines are able to assemble things and create new mashups of content. And it becomes machine interpretable and machine actionable. So with that background, I want to talk about the four futures that we're seeing. And the first one is really almost a reiteration of what I've talked about. It's semantically enriched content. But we're going to go into a little bit more detail. So semantic enrichment is the addition of metadata about the meaning of words and phrases. Now this can consist of terms. Anybody who's worked with localization knows terminology is important. But there's other things, dates, organizations, the name of them, information about them, concepts, information about individuals, relationships. All of these things can add to information about content so it becomes actionable. Imagine if you had instructions for use for something that link to the roles so that you can go in and analyze it and know who needs to perform this step. What is the sequence of steps that need to be performed? So that all can be automated without having a project manager needing to sit there and direct actions. That's the kind of thing that intelligent content can enable. So let's start with a simplified example of this. So I don't know if this is readable, but you have unstructured text. Jose Sevilla has an appointment for a gastric bypass surgery on July 23rd at 10 o'clock with Dr. Johnson at the University Medical Center in White Plains. There's a lot of information in that sentence. And a lot of the information that's relevant actually isn't in the sentence, but it's somewhere else. Which Dr. Jones? What White Plains? What year? All these things that go on. Which Jose Sevilla? So we see the ability to add information, and this is just a kind of representation for what can be done, where it starts tagging and it says, okay, this is the person with the name Jose Sevilla, and they have an identifier. In this case, the email address. Now we know that this whole thing's describing a medical procedure, and that we can link to an authoritative information source about gastric bypass surgery. And then we give the precise date and time in what's called universal time coordinates. So we know there's no ambiguity. And then we can link back to who the doctor is who's doing this and the address of the place. So that all this information that isn't actually in the words you see, but is in the collective knowledge of people, is made explicit. And now machines can act on it. Here's another example from an enterprise website. This is from HPE. If you see there's some blue underlines in this text about blockchain that link to more information. Those have probably been added manually by someone, just given what's there. But imagine you could run a process that starts identifying everything in this that somebody might need to know about. And so it enriches the experience for somebody who comes and says, well, I don't know, what does level of trust mean? It may seem obvious to you, but somebody may need to know that. If you can have machines enriching this content, increases the value and adds metadata. So what sorts of metadata are we talking about? It's the total of an organization's knowledge about items in content. So what's the definition of an item? What product line does it apply to? What is it part of? What parts belong to it? What tools do you need to work on the item? Who's responsible for it? When does the content apply? Imagine you have something about a sale and you'd like to have it automatically disappear when the sale is over so it isn't lingering on your website and confusing customers. And something like the physical description. All these things belong to these semantic networks. And they're information that exists in your organization but previously was inaccessible. We need automated ways to add this. So in the old days, this was proposed in 2008. It's still today largely unrealized. And this was because it was a manual task. Nobody would do it. It was labor intensive, and yeah, there were autocomplete tools, but still didn't meet needs. And it was never anybody's core responsibility, and it took too much knowledge on the part of the author. Large-scale endeavors failed as a result of this. There just weren't the data mechanisms and support to do it. So it was a great idea. It was ahead of its time. And even if you did try and do it, you were hampered by the lack of semantic resources. But today it's possible. So there's a class of technologies, SDL, because we're here, I'll mention, does some of this. It's called automated content enrichment. And this is what I think one of the most exciting technologies right now, but I'll just say, usually when I describe this, people's eyes glaze over because they don't get it. This is technology that goes in and starts adding this and presenting it to various users at various stages of the content life cycle so that they can act upon it. And those could be machine agents or human users, and they can enrich the content and add value. So ACE is It removes that manual aspect and makes this something automatic for you. Now, the linking mechanisms that allow this have now become mature and robust. A lot of the work was done in European Union projects. If anybody really is interested in them, come and talk to me about them later. I was involved with some of them. I won't claim I was behind them, but I was involved. There's open repositories such as Wikidata and BabelNet that bring this to the mainstream because they're open. Anybody can access them. But the real value is in your corporate systems of knowledge, which often reflect the way these things were done 10, 15 years ago. So there's an urgent need to update systems to allow this. And again, because we're here with SDL, I'd say that I'd look at some of what SDL is doing, and it really is a good option for this, or what Klaus at Kaleidoscope is doing. They're great tools to support this kind of thing. However, the internationalization of these features, by and large, tends to be in its infancy. I'll come back to that. Well, actually, I'll move right on to it. So this is an example of a standard to support semantic enrichment. It's called schema.org. And schema.org covers all kinds of stuff, and it allows you to identify roles. So in this one, an example, it allows you to identify that there's a name of a medicine, that it's a kind of drug, that it's used for certain things. You can get the idea of what's there. It's a little bit geeky looking, but it's understandable. The problem that we see with applying these today is that a lot of tools don't support it. So we still have problems with enrichment being accessible in Word or Adobe InDesign, the kind of places you'd like to see it. And there still are some manual tasks. So if ACE is only available in a few niche applications and most tools don't support it, then you're forced to start doing it manually. And then a few organizations have really prepared their knowledge in ways to support it. A lot of them don't yet see the need, or they lack the resources. I think that's short-sighted. If you take away one thing from today, and again, SDL will like this message, and is start preparing your ontologies, your taxonomies, your systems of corporate knowledge. That is the gold that you need for what's going to go on in the next few years. Even if you don't yet see the need, take this part seriously. This is going to be vital for intelligent content. Practical steps, if you want to move in this area, is don't try and boil the ocean. Really start small and build on early success. If you have terminology management, you've got a leg up over most enterprises. If you don't have that, start working on new product lines where content has yet to be established so that you can start building this and rolling it out as you're developing the content. It's much easier to build new content the right way than to retrofit old content. Start with shared standards. So schema.org I showed. There's also Dublin Core. It's a much smaller thing that some people use. They have their problems, but they're the best options today. And then significantly, if you're working in a translation environment, you need to make sure that this metadata is preserved. Far too many tools look in it and say, I don't know what this is, toss it out the window, and then your translated content is dumb. It's no longer intelligent. And this is why an integrated ecosystem of tools often offers you the best choice, because the tools respect each other, they know what they have and to expect. If you're interested in doing this, there's guideline from the World Wide Web Consortium for something called MLOAD, Multilingual Linked Open Data, and this is what you should be looking at if you want to invest in this. And you need to start assigning URIs for your content to allow linking. This is particularly important for corporate systems where you may not have a way to address this remotely. Instead, you're relying on some sort of linking mechanism that isn't necessarily accessible. You need to update systems to allow unambiguous linking to concepts. And then where you're able to, you can adopt ACE to simplify addition of metadata. There's an EU project called FREEM. It finished a few years ago, but it was really the first attempt to deploy this multilingually. And that's a good place to start. Okay, the second future we're looking at is machine-generated content. Machine-generated content is already everywhere. If you go and you look at YouTube, there's huge numbers of videos that have been generated by machines. And actually, in some cases, you aren't the intended audience. This is all about gaming search engine revenue and other stuff. They generate videos that other machines watch. As crazy as that sounds, this is some estimates that say that this amount of content exceeds that's written by humans. Now this can range from simple to complex. You can have template-driven items to ones that are algorithmically generated reports. We'll show some examples. And you may have multiple devices collaborate to create content. So the example I have here is maybe you have an internet-connected door sensor, and it sends an alert to a camera and turns the camera on when it detects something going on. The camera captures an image and creates a message about it. And that notifies your security monitoring system, which compiles this information, creates text that never existed before and only arises as a result of this change, and sends it to you and the police, and then you decide what to act upon it. Now, of course, what happens when these systems don't use the same language or you sell them internationally? Fat lot of good it does your system if it composes a message in English, but you're in Russia. And so there's an urgent need to try and update these things to work internationally. Now, here's an example of machine-generated content that's using a template. I have no idea what this company does other than spam ad comments on blogs. But it updates based on where you are to try and make you think it's local. So I was in Chicago and I got Chicago. I was in Warsaw, Poland, where clearly this company isn't doing anything, and yet it still said Warsaw, Poland. And then I created the Ulaanbaatar, Mongolia one, assuming it would probably do the same thing there. But all it's doing is substituting in little bits of content. Another example is using sensor data to create new content dynamically. So this I set up AccuWeather. It's displaying the weather for Machu Picchu, Peru, in Finnish. And it's using, now this one didn't, but I actually had it set up to use American customary units for temperature, so Fahrenheit. And so you get all these mashups that is generated. What's significant here is this content did not exist until the moment I requested it. And then it was assembled algorithmically and from templates to create something that was presumably would be important to me if I were a Finn in Machu Picchu. I'm not a Finn, I'm not in Machu Picchu, but great example, I think. And then you see where it broke down, though, that you still get the English language ad, which presumably you don't need to know about. So machines excel when content follows predictable patterns, like the weather or that simple location-based substitution. They're also very useful when you need content on demand to meet immediate needs. It works best when you have well-defined knowledge domains, which presumably if you're here from an enterprise, that means you guys. You have product lines, and those are well-defined, and so you can start taking advantage of this. Or in cases where you just have low user expectations about fluency or accuracy, and hopefully that doesn't describe any of you. But we see huge amounts of absolutely garbage content generated by machines. So where does it play a role? E-commerce is a huge area for it right now. A lot of machine-generated content is to address SEO and marketing concerns. And to, if you look at eBay content, there's all kinds of strings, product description strings that were not written for you or me to read. They were written by machines for other machines to read, and then hopefully serve it up to us. But it's all about trying to game it, and it's all generated automatically. It's also useful for data-driven publication, social media promotion. A lot of that's driven by bots. And support environments, where you can create custom support documents, chatbots, and so forth. When we look at the challenges, a lot of this still has questionable fluency. If it's templated, it can be really good, but algorithmic processes can lead to unexpected results. And I was just experimenting with this, nothing to do with this. I was generating fake religious sermons using AI-driven things. And if you don't pay attention to what it's saying, it sounds good. If you pay attention to what it's saying, you assume the preacher that it's mimicking was having a psychotic break in the middle of the sermon. And if anybody's curious, I can share some of those results for you. My favorite title, by the way, was Patience, a Marvelous Bear Trap. So, or the other one, Chastity, the Source of Anxiety, where if you had truth in advertising, that's probably quite a true one. Another area that's a challenge is the need for instantaneous translation. So a lot of this machine-generated content has a short shelf life, seconds to minutes, an uncertain value. And the fluency problems that arise when it's generated automatically can make make MT very difficult. In addition, the output, when it's flattened and delivered up, may then lack the semantic cues that were behind it. So that the intelligence that goes into content is often removed when it's rendered. So practical steps, if you want to work around some of this, is start embedding semantic information into templates and processes. This means using microdata, segment strings to facilitate translation. It means if you see something like Galaxy, Note, Tab, iPad, blah, these kinds of strings you see on eBay, put span tags around it so that MT can pull it apart and know that Galaxy Note goes together and not Note iPad, or whatever the sequences would be. Follow W3C standards and internationalize your processes. ITS 2.0, that's internationalization tag set, has a lot of really useful stuff in this. The MLOAD I've already mentioned. And then if you're working on this, plan for cultural and legal requirements around the world. So organizations can be responsible for what machines generate, which means you have to be very careful when you have machine-generated content that it isn't serving up something weird. If you're using training data and AI to generate this, for instance, you want to make sure it isn't going to serve up profanity to your customers, which is the kind of thing that can happen. So you have to build in safeguards. And make sure that you account for legal and cultural norms. That's a huge topic, more than we can cover today. Okay. The next area I wanted to talk about is conversational content. And I mentioned this in the panel today. So I'm going to give an example. Conversational content is where you interact using human language, or possibly even just things like press 1 or 2. There's various ways to conceive of it. But think of it as being like an old choose-your-own-adventure storybook, where it adapts to what you choose, and it isn't just simply pushed out. These require a sense of state and history, and I'll explain what this means a little bit. But this has to persist across channels and across languages, potentially. So here's an example about lacking state. I use Siri, and I say, hey, I need to go to Chattanooga, Tennessee, and it gives me directions. And I go and I look at those directions, and I come back 10 seconds later, and I say, hey, what can I eat there? Now, this ends up giving me now information about stuff in my hometown, not Chattanooga, because the request I had about Chattanooga has disappeared down the memory hole. Now, any of you who've used Siri, it's like dealing with an anterograde amnesiac who immediately forgets what you have. It's frustrating. It's not terribly useful. With regard to the cross-channel bit, this is very important. So support increasingly crosses channels. So say that you have a support interaction, and the first thing you do is you go online and you visit a knowledge base, and it gives you something, and you try it, and it doesn't work. What's your next step going to be? What will you do after that doesn't work? Okay, it could be Google. Actually, it's probably going to be better than what you get from most companies themselves. Google seems to know more about their content than they do themselves. But let's say that you see a chat option. You say, okay, great, I'm going to use on-screen chat. And that machine chat, it may be machine generated. I've already tried what the knowledge base says. What is the chat going to tell me to do? Exactly what I've already done. And the chat may not progress until I tell it repeatedly, yes, I've already tried this. And eventually I reach the end of what the chat does, and now I hit the human support agent. What's the first thing the human support agent going to do? Yeah, did you turn it off and on again? Or whatever it is. And it's exactly, yeah, so now for the third time I'm having to say this. So each step typically requires a repetition of information because no channel knows what happened in another channel. And this leads to increased costs and user frustration. Now imagine too that you might be crossing language boundaries, so even if there was a log that the support agent could use, they might be in German, and now you're into English because you don't offer German voice support. And so now that's lost as well. Now, each step in this may have business or legal implications as well, so you need to have consistency across it. So some of the challenges that lead to this, really this lack of state, is around data privacy and legal requirements. They limit you being able to store state. So what happens when you know what customers have searched for and done? Let's say that somebody came to a service, a medical service, and was asking about how to treat a sexually transmitted disease. They don't want to expose this to the world. And so there's good reasons why these applications lack state. And it has to do with data privacy and security. And today, it's almost impossible to track conversations across channels. We're starting to see improvement in this, but once you mix in all those multiple languages, the technology falls short. And then there's lack of standardization. So there's ways to represent this, but it might be particular to one tool, to one company. And the moment you start trying to do mashups and you lack a way to store this so that an application could represent state and share it, it falls apart. And here's a crucial one. Your terms are not your customer's terms. So you may have done a great, fantastic job of terminology management, and I laud you for it, it's important. But if you insist that, well, we'll take Samsung for an example, have a Galaxy Note tab. It would never, ever, in a million years, call that an iPad, because that would be legal problems. But you can bet your customers, if you're Samsung, are coming in and saying, how do I turn on my iPad? Or how do I turn on my Samsung iPad? And you need to be able to interpret this and act upon it and not say, I'm sorry, I don't know what an iPad is. That's just going to drive your customers away. And so this conversational content needs to be able to work not just with what you wish people would say, but what they actually say. And you need to be able to segregate those so you don't accidentally start spitting out the wrong terms. You want to still use your own corporate terms. You just need to understand them. So some of the solutions: have opt-in mechanisms to track data. Get consent and track only what you need within that customer journey to allow this conversational content and customer experience to flow unimpeded. And particularly if you're working in Europe, you need to allow users to view what data you do have and to delete it. You can also warn them, say, if you delete this, you won't be able to do X, Y, and Z, but you provide informed choice. Build intelligence into logs and history. So you need to use structural representations of what happened. That means adding the semantic tagging into logs if you use them, and consistently label them. Expand terminology management to include term discovery. This is how you're going to find out about how your customers are talking about your brand and products, and not just the way you think it is. You'd like to know, what do they call my product in Swahili? How are people actually talking about this? And increasingly, I'd say this is still a little bit out there. There's tools that allow this, but it's still not quite in the mainstream yet. But this is where it needs to head. And then build state and complex chains into your tools. This does require corporate buy-in and support, and you'll need to talk to legal teams. It isn't easy, but this is where you can take it to the next step. Okay, the fourth future is headless devices. This is where we start moving away from screens and keyboards. So probably many of you have these. You recognize the Google Wi-Fi product. That has no user interface on board other than a flashing light that looks something like the old Cylons in Battlestar Galactica. It conveys no information to you, I think, unless it turns amber and then it says there's a problem. So all of that information is offloaded into an app. Similarly, if you look at HP LaserJet's UI, it consists of two lights that are either solid or blinking, and if you're like most people use it, you look and say, I don't know what it means. Because it's all, again, handled somewhere else. So Internet of Things and the development in speech technology raise the bar because IoT, Internet of Things, usually lack any built-in user interface. Other devices use voice control, if you think of Alexa or those sorts of things. If we want to reach the next billion people, and I think that Google yesterday used that term, it's going to require speech support, not just in a few languages, but in hundreds of languages. This is a challenge because today, if you want to add one language to something like Alexa, it can take years. So how are we going to handle hundreds of languages? And if you want to get on a little bit of soapbox, it's not just about profits, it's also about human rights. If you want to extend the benefits that those of us, by virtue of sitting in this room and speaking English, have to other people, we have to find a way to do this, and usually that's going to be through speech. Another challenge that we see is that input and output really are a mix of human and structured content. And that means there isn't a single translation mode that will meet everything. And the devices require always-on internet and heavy pre-processing. Now, some of the challenges we see that speech really is only partially solved. So if you look at the market leader, Nuance, they say they support 53 languages and 17 dialects. And by our calculations at CSA Research, that's 96% of the online market. If you look at the offline market that we might want to reach, it's considerably smaller. It's probably something like 70%. I don't know the exact numbers. But that sounds great, but speech and accents and speech difficulties can make systems unusable. Many of you have probably seen the video of the Scottish guy in the voice-activated elevator saying, "Take me to floor 4," and then he's trying to say floor 4 and sound American to make it work, and doesn't quite get it. I mean, that's humorous, but it highlights something real. And even tech giants are suffering delays because of these issues. One of our clients, very large company, wanted to deploy one service every 3 months along these lines in one language other than English, and couldn't hit that target. And they have potentially thousands of services they'd like to deploy. So it doesn't do great when you go to the CEO and say, "I've got a solution, it's on a 10,000-year plan to meet demands." Headless devices often have limited storage power and limited storage and processing power. And so if you want to start adding hundreds of languages, you can't do that either. There's just not enough onboard storage. And that means it has to be offloaded somewhere to a remote server. And content for speech and headless devices, I said earlier, you want to be able to deploy everywhere. That's a hallmark of intelligent content. You have to take this into account from the beginning. Because content that's written assuming you can see it, like a numbered list that you can see each step, becomes very different when it has to be done via speech. And so that means we have to change how we write content. And localization providers lack experience with this. Everybody's struggling with it. Some of the solutions, where you can constrain user input to predictable options. So say, if you need to install a new printer, say install printer, rather than asking, "What can I do for you?" Because then you don't know what you're going to get. Scope your requirements early on, not early one, and break interactions into logical steps. And then also plan for your semantic enrichment from the beginning. Start doing this even if you don't see the need yet. And ACE can help with this. And I mentioned earlier offload processing, although this has its own challenges because sometimes these devices need to operate when you don't have an internet connection. And what are you going to do then? Also, these devices you put them out now, they may be around 15, 20 years from now. Think of IoT light switches. People don't want to replace those every few years. Maybe there's a speech component to something like this. You now have to consider, how are we going to support this in 15, 20 years when the technology's moved on, but that thing's still out there and still needs to be able to phone home. When you develop hardware and software, you need to make it so it can support improvements. That means adding extra memory, perhaps, beyond your current needs. Allow your firmware to update easily without the user having to pat their head, chew gum, and ride a bicycle at the same time. And internationalize what's there. You also need fallback mechanisms. So now I'm going to go on. Last section here is dealing with the information gap. What do you do when you don't have the data that you need to support some of these intelligent content things? Data availability is a huge challenge right now. Data to support intelligent content applications typically exists in only a few languages. And just because of where the economic stuff is going on, that means English and Chinese. If you're lucky, you might get Spanish, French, and German. Move beyond those, and it's an absolute desert right now. You want to add Korean, you want to add Italian. You'd think those are obvious targets, but the data doesn't exist. One of the ways you can address this is that typically organizations discard huge amounts of relevant data. They ingest it and they immediately delete it. So you need to have processes to capture what your users are doing, how they interact with your content. And and make sure that you store this so that you can repurpose it down the road when you see the need. Interpreting non-English data is actually really big because there's a lack of basic technologies. I will say SDL's newest offerings around content intelligence are starting to address this. Not for every language, but it's headed in the right direction. And this is going to be crucial. You need to be able to mine data, so identify unexploited sources of data relevant to your company. This could be things like chat and support requests, data logs for cloud-based services. But again, here you have to be aware of privacy concerns. Your terminology data, I keep coming back to that. That's one of your best resources. And then you need to develop collection plans to capitalize on the data. And I'm not sure why my animations disappeared here. Now you get to see everything before I say it. Another source is data crawling in public data sources. So they're what are called purpose crawlers. These are things that will go out and find data relevant to some topic on the internet and collect it for you. So this allows you to leverage published data, but you can run the risk if you're training applications on this, it may overfit to your competitor's language. So you do have to be a bit careful about it. And it's limited to certain kinds of content, such as support requests, but it may miss other things. There's public data sets. The EU publishes a lot of these, but they may be limited in their applicability. And then I mentioned BabelNet earlier. So these sources are useful, but you always need to supplement them with your own data. Don't rely just solely on public data. And then this leads us to data manufacture. This is creating content specifically to address needs. This can be done automated or manually. Automated is better. And it allows you to address gaps in your content. Beware of anybody, though, who tells you, hey, we can supply this by using machine translation. That's about an 80% solution. One of the big gaps that we find is cultural relevance and other limitations. The moment you move outside of English, things that work in English may not work. And so you can use it as a starting point, but you need to move on. Okay, and I guess I did have one more section. We'll hurry because we're basically out of time. But some of the steps for a better content strategy. Future-proof your strategies. Don't be reactive to trends. Plan for the trends I've discussed. Aim for where you want to be and not just where the technology can take you today. Keep up to date on changing trends in UI. Manage terminology at the next level. Today's terminology management is largely about controlling language, but tomorrow's approaches will be about understanding language in use. This is a big shift in terminology management, and it's incredibly valuable when you can do it. Semantic enrichment means you need to document your knowledge in language, and that means building ontologies and taxonomies, and start with simple cases so you can build experience and expertise. Put semantic information online. This means expose your terminology. Don't see it as something you jealously guard in-house. Put it out there. Its value is when other people can access it and point to it, and you can point to it publicly. And so if somebody sees an unknown term on your site, they can click on it and see what you have to say about it. Make URIs internally. I already mentioned this. You may be confidential information. You still need to be able to point to it. And keep those links simple and straightforward. You don't want people to have to log in, jump through multiple hoops to see it. You want to have direct access. Control your access outside of the linking mechanism. Build templates with enriched data. Embed semantic links in your published content. Now, even if readers won't notice this, it allows machines to act upon it. And you use microdata or what's called RDF formats to ensure interoperability. You want to support conversational states, so build mechanisms to save state. That's the most difficult thing. It's where we want to get to. So you need to find opt-in mechanisms that allow you to do this and provide advantage to customers and inform them why you want to do it and tell them what they get from it. Allow conversations to cross language boundaries, also a big challenge. And I think I'm almost at the last point here, is building your capacities for alternative modalities. So speech. What about augmented reality or wearables? These are things that are important. We heard from Zimmer Biomet yesterday about Apple Watches, and 5 years ago they never would have thought of it. And we have to engineer the data formats to be independent of representation. And now here's another challenge that has yet to be solved. How do we start applying semantic enrichment to audiovisual content and other things? The standards aren't there yet. They have to be there. This is where the market's clearly going. For now, the best we can suggest is start saving this information in metadata about your content. And that will enable things. And with that, that's the end of the presentation. I hope it's been useful. If any of you are interested in the report that this was based on, normally we don't give reports away, but for anybody who's attended, just come and leave your business card with me and we'll provide this report to you, just complimentary, if it's useful. And you're certainly free to reach out to me and ask any questions after this as well.